This video is going to be on writing formulas and names of binary ionic compounds. Okay, so binary just means that there are two elements involved, like copper and bromine, tin and iodine, magnesium and oxygen. It doesn't mean that there couldn't be more than one atom. Like you could have like that, where you've got one atom of calcium, two atoms of chlorine, but binary meaning there's just two different elements involved in these. Okay, so we'll do ionic compounds that have more than two elements. These only have two. Ionic, this is a key. You've got to always know what you're writing a formula for. Ionic means that there is a metal and a non-metal. Okay, copper's a metal, bromine's a non-metal. Tin's a metal, iodine's a non-metal. So the metal's always listed first, the thing left of the stair step in the periodic table. Non-metal second. Okay, ionic meaning you have a positive and a negative together. So this is a positive charge, that's a negative charge. This is a positive charge, that's a negative charge. That's a positive, that's a negative. So these ionic compounds, you always have a positive and a negative, and you're just trying to equal out the positives and the negatives. So we drew structural formulas for them before with the dots and the bonds. Now just a little bit simpler way to write the formulas without drawing them out every time. So here's a way to go about this. So remember when we did structural formulas like magnesium oxide, we looked at magnesium. Don't tell you this. Magnesium has 2 valence electrons. Oxygen's got 6 valence. Well, magnesium wants to get rid of 2 electrons, meaning it has a +2 charge, getting rid of 2. Oxygen wants to gain 2 electrons, meaning it has a -2 charge. So we go bond and bond. You need 1 magnesium with 1 oxygen to form a compound. So instead of doing that every time, drawing them gets a little long. We look at magnesium's charge in the periodic table. First element's always positive. Magnesium's a +2. Oxygen has 6 valence. It's a -2. Remember that the families all have the same number of valence electrons. We want those to equal out. They do. All that means is this is giving 2 electrons to oxygen. Formula is MgO, meaning there's 1 atom of magnesium and 1 atom of oxygen in that compound. I'm going to skip around here a little bit. Aluminum nitride. Aluminum is a +3. Nitrogen's a -3. So whenever the charges are equal, you just need 1 of each thing. 1 aluminum reacts with 1 nitrogen to make aluminum nitride. Potassium sulfide. Potassium has 1 valence electron. It forms a +1 charge. Sulfur's got 6 valence. It forms a -2 charge. So, and I almost always write those charges over here on there so I know what they are. There'll never be charges in here. So we want these to be equal. Like +2 and -2. So I need to double this first one. I'm going to double the number of potassium atoms so that that's now a +2 to overall. And this is a -2. What that means is each potassium is losing 1 electron. This 1 sulfur atom is gaining 2 electrons, 1 from each potassium. So K2S, kind of like H2O, meaning there's 2 atoms of potassium, 1 atom of sulfur. I'll pause for just a sec. All right. If we were doing calcium bromide down here, calcium has 2 valence. It forms a +2 charge. Bromine's got 7 valence, which means it wants to gain 1 electron. It's a -1 charge. Well, these need to be equal. So I got to double this. I'm going to double the bromine, so now I have 2 negatives and 1 positive. Calcium's giving away 2 electrons. Each bromine's gaining 1. Scroll down a little bit. Let me do aluminum sulfide right here. So aluminum has a +3 charge. Again, you can find that on your periodic table. If you've got a periodic table with charges on it. If not, I will send one to you. Sulfur's got a -2 charge, for those of you that are online. So we need these to be equal. Okay. So if we have +3, -2, we need the other to get to +6 and -6. This is going to get doubled, and sulfur is going to get tripled. Really, whenever we do these, we're just flipping the charges. This 2 means I need 2 atoms of aluminum. This 3 means I need 3 atoms of sulfur. That will equal out the charges. So aluminums are giving away 6 total electrons. Sulfurs are gaining 6 total electrons. 3. It's going to be 2 per sulfur atom. All right. If you notice these on this side, these have got some Roman numerals in them. Okay. You'll see Roman numerals whenever there is a transition element. Okay. An element in the D block of the table. So whenever you see transition elements, you will see some Roman numerals. I don't know if I have a periodic table open. No, I don't. Oops. So when you see an element in the middle of the table, those form multiple charges, like copper forms 2 different charges, tin forms a couple different charges. So elements in the middle of the table and tin and lead. So elements in the D block of the table, the transition elements, and tin and lead. Whenever you have those, there will be a Roman numeral telling you the charge. So that Roman numeral does not tell you how many atoms there are, it tells you the charge on copper. So I know copper is a positive because the first element's always positive. So copper's charge here is a +1. Look at bromine, which is a -1. Those are equal. 1 atom of copper, 1 atom of bromine. Tin here, that 2 means that tin has a +2 charge. It does not mean there are 2 atoms of tin. Iodine is a -1 charge. So I need to double the iodines, or you're flipping your numbers. I need 2 iodines, 1 tin. Iron 3 chloride, that 3 tells you that iron's charge is a +3. That's all the 3 tells you. The chlorine we have to look up in the periodic table. It's always a -1. Again, the reason there's a Roman numeral for these is iron has multiple charges it forms. It can be a +2 or a +3. Those elements in the D block of the table can form multiple charges. So we need here Fe and Cl. We need 1 iron, 3 chlorines. Let me do a couple more. Lead. Lead is a +2 charge. Oxygen's a -2. Remember, if those charges are equal, you just write 1 Pb, 1 O. I do want to show you one. I don't know if I have one on here like this. Let's say we have this. Let's say we have tin that can be a +4 charge and oxygen that is a -2. So again, we're trying to equal those charges out. So if this is a +4, I want that to be a -4. So I would need to double my oxygen to get that to a -4. So SnO2. All right, those aren't too tough. Writing names of them is easy most of the time. So if I'm writing these names, I'm just going to do a few of these. There is something weird about some of these, though. So first thing, I just say lithium. The 2 there does not make any difference. It makes no difference at all. I just say lithium. So name the first element normal. Second element, we change to "ide" on the end. So lithium oxide, aluminum chloride, magnesium sulfide, calcium oxide, potassium bromide, sodium nitride. So first element you name normal, second element you put an "ide" on the end. Lead sulfide, tin oxide. All right. The only thing is this. If the first element is in the D block of the table, first element is a transition element, or if it's tin or lead, a transition element or tin or lead, we have to put a Roman numeral. So that's a transition, excuse me, that's tin and lead. Nickel's a transition element, copper's a transition element, there's lead, there's iron. Okay, sodium and magnesium are not transition elements, so we do not need Roman numerals there. Sodium's always a +1 charge, it's in family 1. Magnesium's always a +2 charge, it's in family 2. So those don't need Roman numerals, but these other ones do. So we name them the same thing, so Pb is lead. I'm going to put some parentheses for the charge of lead, and S is sulfur, which we change to ide. So we need to know what charge lead is. Lead's got a couple possible charges. If you look on the periodic table, it's got 2 of them. The way I get that is I figure out the charge on sulfur, because that charge is always the same. So look at the periodic table. Sulfur's charge is a -2. Well, lead's got to equal that out. So if sulfur is a -2, lead has to be a +2. So my Roman numeral there is a 2, meaning lead's charge is a +2 charge. SnO2. So Sn is tin. Put my parentheses in there. Again, tin needs a Roman numeral because it forms multiple charges. Oxygen becomes oxide. So here we have 1 tin and 2 oxygens. We need to look up the charge on the nonmetal because oxygen's charge is always the same. So oxygen's a -2 charge per oxygen, but there's 2 oxygens. That's a total of -4 for the 2 oxygens. That means tin must be a +4 if these 2 oxygens are a -4 total. So tin's Roman numeral is a IV, or 4. IV means 4. Again, These don't need Roman numerals because sodium, magnesium are not transition elements, or tin and lead. I'll do a couple more of those. Nickel and oxide. So again, we look up the charge on oxygen. Oxygen is a -2. There's only one of them. That means nickel must be a +2, so Roman numeral is a 2. Let's go down and we'll do lead. Chloride. So we look up chlorine's charge. Chlorine is a -1, but there are 4 chlorines. So we have 4 chlorines. Each one is a -1 charge. That means that's a -4 total. Well, if this is a -4, lead has to be a +4 to equal it out. So lead's charge there is an IV. So charge can be a little bit tough to get. Again, not all of them need that. If that's a part right now that's tough for you, that's okay. All right, that's it.